Welcome to Dataverse by Nina Paul. This is episode 36, and today we are jumping into a really specific, just incredibly frustrating mystery.
Oh, it really is. It's a nightmare for developers.
Yeah, it's one that's been quietly sabotaging data teams everywhere. So in this deep dive, we are talking about Tableau Pulse. And specifically, a scenario that, well, it might hit a little too close to home for you listening.
I guarantee it has happened to a lot of people tuning in.
Right. So picture this. You spend hours, maybe days, architecting this beautiful, elegant rolling average, and you're working inside the advanced analytics editor, and the preview, it renders flawlessly.
Smooth trend line looks perfect.
Exactly. You are looking at this perfectly smooth line that tells a crystal clear business story. You hit publish, you distribute it to your leadership team's live feed, and then the live metric instantly flatlines.
Just completely dies.
Or it just breaks entirely, right in front of the executive team.
Yeah, it is the absolute definition of a silent failure. The heartbeat monitor just drops to 0, and you get absolutely no warning bells during the development phase.
Which is terrifying, honestly.
Oh, completely. Because when your professional credibility is tied to the numbers on that screen, watching a core metric fail in a live executive environment, just the worst feeling.
So our mission for this deep dive today is to pull apart the machinery, and uncover why this silent failure actually happens. And here is a bit of a spoiler alert for you. It is not your fault.
No, not at all.
It's a fundamental platform limitation. So we're going to explore the mechanics of that limitation, and more importantly, how to fix your architecture before it permanently destroys your team's trust in your data.
Which is the real risk here.
Right. But to get there, we need to diagnose the root cause, which it usually starts with a pretty simple vocabulary mix-up. Okay, let's unpack this. What are we actually trying to build when we tell a piece of software to make a metric, quote-unquote, rolling?
Yeah, so in the Tableau Pulse ecosystem, there are two distinct features that actually share the word rolling, and casually conflating them, that's behind almost every failed setup we see.
Just a misunderstanding of terms.
Exactly. You have the built-in rolling date window filter, and then you have a rolling average metric definition.
And to a casual user, or even a stakeholder requesting a dashboard, those sound like the exact same thing.
They really do, but functionally. They operate on completely different layers of the software.
Okay, so the rolling date window filter, that is what most of us interact with every day, right? That's your standard drop-down menu that says like last 7 days or last 30 days.
Right, and that filter is purely a display setting. It simply shifts how much historical data is visible to the viewer. It establishes the comparison period, but it never touches or modifies the underlying aggregation of the data itself.
Oh, I see.
So if you have daily sales numbers that are just wildly spiky, huge spikes on weekends, 0 on Mondays, applying a last 30 days filter just gives you 30 days of those exact same raw spikes.
Let's put a mechanical visual on that. Instead of just looking at the data, imagine you have a physical calendar hanging on your wall, right? With a daily sales number written in every single box.
Okay, I like this.
The date window filter is just you stepping closer to the calendar and focusing your eyes on the bottom 3 rows. You are just looking at a specific section of the raw numbers. It's like looking at a pothole-filled road through a wider windshield.
That's a great way to put it. You see more of the road, but it's still incredibly bumpy.
Right. But what we actually want when we talk about smoothing data is a mechanical calculation. We want to actually pave the road flat so we can drive smoothly.
Exactly. We want a true rolling average metric definition. In this scenario, the mathematical averaging logic is permanently baked into the measure itself.
So it's fundamentally changing the number.
Yes. If you build a 7-day moving average of daily sales, the system is actively recomputing each individual day's value as the mean of the trailing 7 days.
So sticking with that calendar analogy from earlier, this calculation is it's like taking a physical sliding wooden frame that holds exactly 7 calendar days. You place it over the first week of the month, you calculate the average of those 7 numbers, and you write that new smoothed number down, and then tomorrow happens.
And you physically slide that wooden frame 1 slot to the right.
Right. The oldest day drops out of the frame, the brand new day enters the frame, and you calculate a brand new average. The equilibrium is just constantly maintained.
And when that sliding frame mechanism is baked into the metric, everything downstream that consumes that number inherits that beautifully stable number.
Like the executive digests or the automated insights?
Exactly, all those enhanced Q&A features. But the problem we are tackling today is that this True, baked-in sliding frame calculation that is the exact feature Tableau Pulse cannot build natively.
Which is wild.
Yeah.
But before we tear into those software limitations and why it fails, I want to establish the stakes for you listening. Why is this specific calculation worth all this architectural trouble?
Because the alternatives are risky.
Right, because a lot of data teams just default to month-to-date or quarter-to-date calculations, don't they? They rely on fixed calendar periods because they're just easy to build out of the box.
They are easy, but defaulting to month-to-date is a massive operational risk for certain types of high-frequency data.
What kind of data?
Well, if you are tracking daily demand, daily active usage on an application, or customer support ticket volumes, you're dealing with metrics where people make physical, operational decisions day in and day out based on those numbers.
And fixed periods like month-to-date, they reset completely at midnight on the first of the month.
Exactly.
So at the very beginning of the cycle, your metric is running on an incredibly tiny sample size.
For a sample size of literally 1 or 2 days. And this creates highly volatile, skewed signals that can trigger just catastrophic business decisions.
Right. And the source material provided this brilliant case study of this vulnerability. They referred to it as the day 3 trap.
Yes, the day 3 trap is a perfect example. So imagine a mid-sized retailer. And for whatever reason, maybe they're clearing out seasonal stock or trying to hit a quarterly target early. They decide to run a massive, heavily promoted 2-day flash sale.
Okay, makes sense.
But they run it on the 2nd and 3rd days of the new month.
Oh, I see where this is going. So the operations team is sitting in their control room, and they are monitoring a standard month-to-date average demand metric.
Right. And on the morning of day 4, they look at their dashboards. Their month-to-date data only contains 3 total days of history for that specific cycle.
And 2 of those days were an artificially massive, highly unusual flash sale.
Exactly. So the average daily demand for the month looks astronomical. It appears as though baseline consumer demand has just permanently skyrocketed by like 300%.
Wow.
But it is a completely false signal, heavily weighted by the calendar reset.
So how does the operations team typically react to a signal like that when they don't realize the math is tricking them?
Oh, they panic. I mean, they assume they are going to stock out of inventory within the week. So they execute a massive emergency purchase order to their suppliers to keep up with this phantom demand.
But the demand isn't real.
No. As the month progresses, the shale ends, and demand drops right back down to the normal baseline. Now, that retailer is sitting on thousands of units of excess inventory in their warehouses.
Just bleeding cash on storage costs?
Bleeding cash, tied up capital, all because a month-to-date metric mathematically misled them early in the cycle.
And this perfectly highlights the value of that sliding frame we talked about earlier. If they had been looking at a 28-day rolling average, that metric is completely agnostic to the start of the calendar month.
Right, it doesn't care that it's the 4th of the month.
It just looks backward over the last 4 weeks. So that 2-day flash sale gets immediately absorbed and diluted by the 26 normal days surrounding it.
Exactly. The spike barely moves the needle, the panic order never goes out, and they save an absolute fortune.
Same underlying raw data, fundamentally opposite business decisions, based purely on how the aggregation is handled.
It's incredible.
But this brings us to the core mystery here. If the true rolling average is this crucial for volatile metrics, and the financial stakes are this high, like ordering a warehouse full of inventory you don't need, why do seasoned, intelligent data professionals get the setup so catastrophically wrong when they open Tableau Pulse?
Well, it really comes down to deeply ingrained muscle memory.
Muscle memory.
Yeah. The professionals building these executive feeds have typically spent years working in Tableau Desktop. And they have been taught a very specific, very reliable way to build a rolling average.
Right.
They use table calculations. They write a formula using functions like window AVG or window sum. They divide it by the required number of days, and it renders a perfect line chart.
Okay, so logically, when they are tasked with building a pulse metric, they just open the advanced analytics editor.
And they copy their desktop calculated field word for word, paste it into the Pulse interface, and assume their job is done.
I mean, I would do that. It is the same brand, the same software ecosystem. You'd naturally assume the underlying computation engine is shared.
You would.
But here's where it gets really interesting. That mental model of how Tableau processes data does not transfer to Pulse at all.
Not even a little bit. And this is the architectural reality we have to address. In Tableau Desktop, a table calculation is exactly what it sounds like. It is math that runs against the physical table of data that has already been retrieved and rendered on your screen. The software pulls the raw numbers, organizes them into a local grid, and then runs the window AVG math across that visible grid as a final step.
Okay, so the math is happening locally on the glass after the database query is already finished.
Exactly. But a Tableau Pulse metric definition does not possess a local grid in that same way.
Because it's different architecture.
Yes. Pulse operates as a headless automated metrics engine. It runs on a background schedule, constantly querying definitions against a semantic layer to feed insights into cloud-based digests.
Yeah.
And because there is no localized post-query grid being rendered on a screen during that automated background refresh, it just cannot execute table calculations.
Wow. So that is the hard limitation we hinted at during the intro. Tableau Pulse fundamentally does not support table calculations like window AVG or running sum or lookup.
It doesn't. And there is no hidden toggle switch in the admin settings. You cannot request a permissions upgrade to unlock it.
Yeah.
It is a hard architectural boundary.
Okay, wait. I have to push back on this on behalf of everyone listening.
It's okay. Go ahead.
If the Pulse compute engine fundamentally cannot process a table calculation in production, why on earth does the advanced analytics editor accept the formula without throwing a syntax error?
It's a great question.
Right. Why does it generate a perfectly smooth, beautiful preview chart? If the software knows it can't run the math, isn't presenting a working preview an incredibly dangerous illusion for developers?
It absolutely is. And what's fascinating here is how the software architecture inadvertently creates this exact illusion. Well, senior Tableau consultant Surya Prakash M. Detailed this phenomenon in the sources. The advanced analytics editor is functioning purely as a sandbox preview environment.
A sandbox. Okay.
Right. It is designed to show you what your calculation would theoretically look like if it were rendered locally. But the editor does not validate whether the background Pulse compute engine can actually execute that specific syntax in a live automated environment.
Wow. So the editor is essentially saying, here is what this math looks like in a vacuum, completely ignoring the reality of where the math eventually has to live.
Yes. The preview environment and the live production engine are playing by two completely different sets of processing rules.
That is a trap.
A huge trap. The developer pastes in the unsupported table calculation, the sandbox renders the visual perfectly, and the developer confidently hits publish.
And then what?
The second that metric is deployed to the live Pulse engine, the automated query attempts to run, hits the unsupported table calculation, and fails.
Just crashes.
Yeah. It might fail to load entirely, it might return a flat zero, or worst of all, it might return a completely chaotic, incorrect number.
The silent failure, I mean, it bypasses the developer's quality assurance because the preview literally lied to them and it goes straight into a live executive dashboard.
Day to the top.
We need to talk about the blast radius of that silent failure because we aren't just troubleshooting a broken line on a chart here. We are talking about the rapid destruction of data culture within an organization.
We really are. Consider the delivery mechanism of Tableau Pulse. These aren't just reports buried 3 folders deep on some dusty intranet site.
No, people are looking at them.
Right. These metrics are pushed directly into leadership digests. They're surfacing in Slack channels, Microsoft Teams, directly into the CEO's email inbox every single morning.
Oh, man.
So if a flatlined or highly inaccurate rolling average sits in a chief operating officer's feed for 3 days before a data engineer catches the mistake, the damage to your data program is already done.
Yeah, because once an executive spots a glaring error in one metric, the psychology of trust evaporates instantly. They don't quarantine their doubt to that single rolling average.
No, they instantly assume every other metric in that digest is equally flawed.
And the financial impact of that lost trust is severe. I mean, the sources point to Gartner research estimating that poor data quality costs organizations an average of $12.9 million per year.
That is a staggering number.
It is. And furthermore, a Salesforce State of Data and Analytics report revealed that data leaders themselves rate roughly 26% of their own organization's data as untrustworthy.
Just think about that combination. When you combine those two statistics with an automated system quietly pushing unsupported broken calculations to the C-suite, you can see exactly how a company bleeds millions of dollars through misaligned operational decisions.
Okay, so we have thoroughly diagnosed the illness. We know the difference between a filter and a metric. We know the danger of the day 3 trap. And we know the advanced analytics editor is projecting an illusion.
The sandbox illusion.
Right. Now we have to architect the cure. If Pulse flat out cannot compute the sliding window locally, how do we fix this?
Well, you have to step outside of Pulse entirely. If you are clicking around the Pulse interface hoping to solve this, you are wasting your time.
So where do we go?
You have to move the complex computation to a layer of your stack that is actually designed to handle heavy transformations. You must move the rolling logic upstream into your data layer.
Okay, and by upstream, we mean performing the math before the data ever makes contact with Tableau Pulse or the semantic layer.
Exactly. This is a fundamental shift from visualization layer logic to data layer logic.
Right.
You need to pre-compute the sliding window in a robust transformation tool like Tableau Prep, DBT, or directly within your source SQL database. You execute the complex window functions back where the compute engines are actually built for it.
Let's get technical on how that actually works for a second. If I'm writing this in SQL, I'm using an over clause with a partition by Y and setting the rows to look back over the preceding 27 days plus the current day.
Exactly right.
Hmm.
The SQL engine, or the Tableau Prep flow, does the heavy lifting overnight. It calculates the 28-day average for every single row of your calendar.
And then what happens?
The output of that complex transformation is simply written into your final database table as an ordinary static column of plain numbers.
Ah, so when Tableau Pulse connects to that final table, it isn't seeing a complex table calculation at all.
Nope.
It just sees a column titled, 28-day average demand filled with static decimal points.
Pulse has absolutely no idea that heavy math was involved. It is simply surfacing a pre-materialized measure.
That is so elegant.
It is. Because it is just reading a flat column of data, it doesn't need to run any local grid math.
Mm-hmm.
Everything downstream, the live executive views, the natural language insights, the automated digests, it all works flawlessly because the processing burden was handled upstream.
So what does this all mean? We are essentially tricking Pulse by doing the homework before we get to class.
Exactly.
We run the complex formulas at home, and we just hand the teacher the final answer sheet.
Perfect analogy.
But I do want to push back and take that a step further, because this architectural shift introduces a massive new problem, doesn't it?
I know where you're going with this.
Right. If every single slice of data needs to be pre-calculated in the database, aren't we risking completely clogging up our data layer just to get a smooth line on a chart?
Yes, this is the ultimate scaling catch of the upstream workaround. Because a pulse metric definition relies on pre-aggregated columns, you lose the ability to build one master metric and slice it dynamically on the fly using local math.
Right.
If your underlying logic requires complex upstream pre-computation, every single variation needs its own dedicated column.
Okay, let's play this out. Let's say I need a 28-day rolling average for overall sales. That's one column in my Tableau Prep flow. Easy.
Easy enough.
But then the VP of North America wants their own rolling average, and the VP of Europe wants theirs. Then product marketing wants a rolling average broken down by 3 different product tiers.
It multiplies fast.
Very fast. Suddenly, to get smooth lines on a few charts, I have to generate 30 distinct custom columns in my upstream database. Where's the line between accurate and unmanageable for the listener?
Well, if we connect this to the bigger picture of enterprise data architecture, you have hit on the exact reason why data engineering is a distinct discipline from data visualization.
Guess it gets messy.
Because building 30 columns is easy. Managing them is the nightmare. You instantly run into issues with naming conventions.
Like, does one engineer call it rolling avg 28 while another calls it 28 Devo Vag?
Right. And who owns the refresh schedule for these prep flows?
And what about logic drift? If the North American team decides to change their rolling window from 28 days to 30 days to align with, say, a new fiscal calendar, but they forget to update the European column's SQL logic, your enterprise metrics just slowly drift apart. You lose all standardization.
And this is exactly where experienced data design earns its keep. You cannot just slap 30 random columns onto a table and hope for the best.
Obviously not.
This is why specialized firms like Opal focus heavily on designing robust semantic layers and modular data pipelines. You have to treat your data architecture as a strict prerequisite to your visualization, rather than an afterthought.
So how do you actually govern that? What does that architecture look like in practice?
You implement strict version control and centralized definitions. If you are using Tableau Prep, for example, you build a single certified modular flow that calculates the rolling averages for all dimensions simultaneously.
So the math is centralized.
Exactly, ensuring the mathematical logic is locked in one central location. You enforce a strict data dictionary, so the naming conventions are identical across all regions.
Right.
You create a certified published data source that acts as the single source of truth And you restrict publishing permissions so rogue analysts can't introduce conflicting rolling calculations.
So basically, the software limitation in Tableau Pulse essentially forces you to adopt healthy organizational habits.
It really does. It strips away the ability to use messy, localized quick fixes on the dashboard, forcing you to build a resilient, governed data product upstream.
You architect the solution from the ground up, ensuring that by the time the data reaches the leadership digest, it is mathematically bulletproof.
Yes. If you get the architecture right upstream, the visualization layer becomes incredibly lightweight, fast, and most importantly, trustworthy.
Well, this has been a massive unspooling of a very specific high-stakes problem. So let's briefly recap the journey for the listener, just to ensure you have your defensive architecture in place before you go back to your development environments.
That's good.
First, guard your vocabulary. Do not confuse a rolling date window filter, which merely changes your visual perspective, with a true rolling average calculation, the sliding frame that mechanically smooths volatility.
Second, recognize when your metrics are vulnerable. If you are tracking high-frequency volatile data like daily active users or daily sales, ditch the standard month-to-date calculations.
Use that true rolling average to protect your operations team from false signals and costly overreactions, like our flash sale inventory disaster.
Third, and this is the core technical takeaway, do not trust the advanced analytics editor's preview when you are attempting to use table calculations like window AVG.
Right. The editor is a sandbox, not a validator. It will render a beautiful illusion that will quietly fail the moment it hits the live Pulse engine.
And finally, embrace the upstream fix. Move your complex rolling logic into Tableau Prep, DBT, or your source SQL queries.
Pre-compute the math, manage the scaling through strict governance and centralized data pipelines, and let Pulse do what it does best, serve up clean, pre-materialized insights to your leadership team.
Yeah, that's the way to do it.
So for everyone listening right now, we have a specific, actionable mission for you. Before you sign off today, check your live Pulse executive feeds.
Do it today.
Run them through the 4-point mismatch checklist to ensure your metrics aren't secretly failing in production. 1. Did you use a table calculation in the setup?
2. Did it look perfect in the editor preview?
3. Is it currently failing, throwing an error, or dropping to 0 in the live view?
And 4. Have you verified that the underlying data source is actually refreshing normally?
Because if those 4 conditions are met, you have an unsupported calculation failure. It is time to tear out the local math and rebuild that logic upstream.
It really is the only guaranteed method to protect the integrity of your automated reports.
As we wrap up this deep dive, I want to leave you with a broader thought to chew on.
Okay.
We've spent our time today diagnosing a specific failure in one particular feature of one BI tool. But this scenario points to a much larger sort of concerning trend in modern software development.
Oh, absolutely.
We're seeing a rapid increase in advanced tools that fundamentally separate their user-friendly preview interfaces from their actual live compute engines.
It is the danger of abstraction. As software tries to become more accessible, it hides the mechanical reality of how the processing actually works.
Which brings us back to that heartbeat monitor dropping to 0. If the very screens we rely on to build, test, and validate our reporting logic are fundamentally disconnected from the engines that run them in production,
If the software is comfortably feeding us false positives during development,
what other silent failures might be lurking in the automated systems we blindly trust to steer our businesses every single morning?
it's a great question. It forces us to ask whether we are managing our data or if our abstracted tools are actually managing us.
Keep a close eye on those monitors, everyone. Thank you for joining us on this deep dive. We will catch you on the next one.